when there's a multiplier directly in front of the x, we saw in class, or maybe we talked about how that does a horizontal stretch or shrink. It makes the graph, changes the period is what it does. It changes when the graph starts to repeat itself. And so to figure out what that new period is going to be, here's what we get to do. We're going to focus mainly on this part, right? And what we know is that the cosine function, whatever it's doing at 0, it starts to repeat that at 2 pi, and it also starts to repeat that at negative 2 pi. So this represents one full period of the function where it starts to repeat itself, and this is the second full period. And our graph typically will have those x values, and then we'll break that interval into the 4 equal pieces, one for each one of these quadrantial angles, because that tells us where the x-intercepts are and where the local max and local min, 1, -1, show up. So what I basically want to do is figure out what is the x value that has me evaluating the cosine of 0, what is the x value that has me evaluating the cosine of 2 pi, and then what x value makes me evaluate cosine of negative 2 pi. If I'm not making sense, here's what I mean. I need to figure out what makes this equal 0. So when does 3x equal 0? I want to figure that out. If I use some, 8th grade algebra, we know that happens when x equals 0. So far, this isn't too groundbreaking. I also want to figure out when this equals 2 pi. So when does whatever I'm taking the cosine of equal 2 pi? Well, again, maybe not as pleasant, but dividing both sides by 3, that happens when x equals 2 pi over 3. So whatever the graph was doing between 0 and 2 pi, it's now doing that between 0 and 2 pi over 3. Now I need to take this full period and break it into the 4 equal pieces. If you don't know how I'm getting the numbers I'm about to throw down, they're in the video that I think is called Awkward Interval 3. So you'll want to watch the Awkward Interval 3 video. But basically, the halfway point between these guys is going to be pi over 3. The halfway point of that halfway point is pi over 6. And this one is pi over 2. And in a similar way, I could figure out that this is going to be negative 2 pi over 3. This will be negative pi over 3. That halfway point is negative pi over 6. And this is negative pi over 2. You can do the math on that. Now that I know where these new critical quadrantial points are happening, it's just a matter of me knowing what the heck cosine is doing. Cosine is the graph that starts by going up 1, and then it goes down to the 0 line, and then it goes down to negative 1, and then back up to the 0 line, and then back up. So from the 1, it goes down to the 0 line, down to negative 1, back to the 0 line, back up here. I'm going to go ahead and do my very best to draw this in. It's going to look like every other graph I drew, really, because we're not too careful about scaling our x-axes appropriately, because who's got time for that? But that's what's going to happen. I just need to readjust where those x-intercepts happen and where those local extrema happen. And, yeah, good luck.